Well, hey folks, we're ready to start Chapter 5, Section 1. Section 1 is titled Growth and Decay, Integral Exponents. Integrals are what that means is integers, numbers that are not fractions and numbers that are not decimals. Alright, so we're going to go through some simple examples. Here we have a to the third power times a to the second power. When you have two monomials that have the same base a, and you're multiplying them, you can add the powers. So if you have them a monomial side by side with another monomial, you add the powers. So side by side means add them, add them. I need you to memorize that. Side by side, same base means add them, add them. So we get a to the fifth power. The same works for the next one. Add the powers. 4 plus 3 plus negative 1 is 6. So this really says 2 to the sixth power. And 2 to the sixth power you can put as 64 because it's relatively simple to do. Now here in number 3 we don't have the same base. We have a and we have b to the fourth. Well, that's just a squared b to the fourth. It's not the same base, so that is simplified. There's nothing else you can do with that one. Alright, what about here in number 4? We have 3 squared, which is 9, times 4 to the fifth power, which is 1024. Well, that's just 9,216. The important part about that problem, though, is that you could not add the powers. In number 5, you have a power to a power, so you should do what? Add? When you have a power to a power, that means you multiply the powers. Now, another way to think about this would be a to the sixth times another a to the sixth. Well, now they're side by side. And what's the rule? Side by side means add them, add them. Or you could have just done what I said earlier. 6 times 2, answer 12. a to the 12th power is the answer regardless. And then finally, if you have a monomial with two different variables raised to a power, you multiply both powers. So it would be a to the fifth cubed times b to the sixth cubed. Multiply the powers, answer a to the 15th and b to the 18th. Done, finished, finito. Note, folks, if you have a binomial, that is two different monomials with a plus sign in between them. That's a binomial. You cannot distribute, this is a big no-no, the power on the outside. That's a very common mistake that you cannot make. Whether there's a plus sign, a minus sign. Now, if it's multiplication or division, that's fine, because then it's just a monomial. But when there's a plus sign or a subtraction sign, that makes it a binomial. You can't distribute over a binomial. All right, now, here we go. So what do we do then? Well, that means we need to write it out however many times we have the power. Since this is a power of 2, write out x plus 5 times x plus 5. And now you just use the distributive property to simplify this. Okay, you would do x squared plus 10x plus 25. Notice, this is not x squared plus 25. That's the common mistake that everybody wants to make. You must remember to write it out 2 times. Okay, what about this? If you have a binomial, 2 over x, can you do 2 cubed over x cubed? Well, it wasn't separated by subtraction or addition, so this is fine. This is really 8 over x cubed. Ta-da! And by the way, x can't be 0 here. You might want to make that note, because if it were 0, then the world would fall apart. Okay, but now we have 4 to the third power. That means there's really 4 3's up top and 4 to the first power on the bottom. Well, you learned in 6th grade that you can cancel out a couple of those 4's and you're left with 16. A faster way to do it would have been said, okay, there's 3 4's up top, there's 1 4 on the bottom. Let me not add the powers, but subtract the powers. So, or we could have done 4 to the 3 minus 1 power, which is 4 squared, which is again 16. Okay, now look at the number 10. Here you have the same base. Okay, it's 2 to the 7th power, and the bottom is 2 to the 7th power. Well, let's use our rule. Top power minus bottom power. Well, that's really just 2 to the 0 power. But wait a minute. This said 2 to the 7th over 2 to the 7th. That's like 1 over 1, or x over x. What is any number divided by itself? It's always equal to 1. Well, you could have told me this answer then earlier. This is just equal to 1. That means 2 to the 0 power is equal to 1. In fact, anything to the 0 power is equal to 1. And check it out if you don't believe me. Type in exactly what we just did. 2 raised to the 0 power. Answer 1. There it is. Okay. Let's get that out of the way. Anything to the 0 power is equal to 1. All right, last one here. And now here, a squared's on top and a to the 5th's on the bottom. That means you have more a's on the bottom. How many more? It means you have 3 more a's on the bottom. Think of it as, it was a times a, and the bottom was a times a times a times a times a. And 2 of those a's canceled. Well, if everything cancels on the bottom, that means there's just a 1. On the top, that means there's just a 1 on the top. So this is really 1 over a cubed. Now, you could have done it like this. You could have said, all right, let me use my subtraction rule. 2 minus 5. Well, that's really a to the negative 3rd. But that's a big no-no. You're not allowed to leave negative exponents. So it's really 1 over a cubed. And we'll talk more about that here in a moment. All right, so let's go over all our rules here. Laws of exponents. So if you have some base b to the x power times some base b to the y power, side by side, what do? So you add them. So it's x plus y. If you have a power, I should have written that in there. If you have a power to a power, so if you have b to the x raised to some y power, you multiply the powers. You multiply. Power to a power means you multiply. Get this memorized. Hopefully this song is catchy enough for you. All right, if you have 2 different bases, but they're being multiplied together, it's a product. This is a power of a product. You distribute the power, so it would be a to the x times b to the x. Power of a quotient, so here you have a over b, all raised to some x power. That would be the same thing as a to the x over b to the x. And finally, what if you have, b to the x over b to the y? So mono divide mono means subtract the top minus the bottom power. So it's b to the x minus y. It's always top minus bottom. Okay, continue to move on here. B to the 0 power. Well, anything to the 0 power is just 1. Note that b cannot be 0. Okay, and finally, what about b to the negative x power? We got a problem. You can't have a negative exponent. That b is not happy. He's good. He's sad. He's got a. I'm going to draw a little sad face here. He's sad because he's got a negative power. All right, he would be happier in the denominator. Or what if it starts off in the denominator? 1 over b to the minus x power. He's sad again. Make him happy. He's not happy in the denominator, so he would be happy in the numerator. You can never leave negative exponents in your final answer. You cannot. Okay, a couple notes to make here real quick. All right, if you have a binomial is the sum of 2 monomials. You cannot distribute the power. Same if you have a binomial that's a difference of 2 monomials. Cannot distribute the power. So let's say that. You cannot distribute over a sum or a difference of monomials. Can't do it. Okay, let's jump into a couple saltier examples than what we started off with. Okay, now let's see here. We have negative 4x cubed raised to the second. Well, who's being raised to the second power? The negative 4 or the x? Well, they both are. So this really says negative 4 to the second power times x cubed to the second power times 3x to the negative second power. Well, let's clean that up. Negative 4 to the second power is 2 negatives make a positive. That's 16. All right, here we've got power to a power means you multiply. That's right. We still have times 3, x to the negative second. Okay, now the 16 gets to play with the 3. All this is being multiplied. So the 16 would play with the 3, and the x to the 6th would play with the x to the negative second power. All right, so that's really 48. That came from 16 times 3. X to the 6th times x to the negative second. Side by side means what? Add them, add the power. So this is 48 x to the 4th power. Are you done? Do you have any negative exponents? Nope. You're good to go. No negative exponents, you're good to go. Now, you can check the answer by assigning some value for x, because some people don't know if they're done, like if their answer's right. Well, just pick any number for x and check your initial expression and your final expression and see if it's true. So check this out. Watch, I'm going to draw a line right here. I'm going to do this in red. So negative 4, instead of x, I'm going to put 2. That's cubed, and the whole thing is squared, times 3 times 2 to the negative second. See what that equals. And on the other side, I'll do it in blue. Take your answer, 48, and instead of x, put 2 to the 4th power, and just see if they're equal. Well, 2 to the 4th power is 16, and 48 times 16 is 768. Let's see if the other side works the same. Let's see here. 2 cubed is 8. That's what comes first. 8 times 4 is negative 32. That's squared. Here, 2 to the negative second. Remember, that 2 is not happy, is he? He's not happy at all. Where would he be happy? He'd be happier down on the bottom. In the bottom, it would be 2 squared, which is really 4. So this really says 768. Nope, I'm sorry. That is incorrect. What's 32 squared? Type that in. 32 squared. This really says 1,024. 1,024 times 3/4 is what that really says, which is in fact 768. So we know that at least our answer, the expression is the equivalent of the original expression. Okay? All right. Okay, now they get fun. Now they get real fun. Okay, question. Can we do the following? Can we say that a to the negative second power plus b to the negative second power is the same as a to the positive second power plus b to the positive second power? Yes or no? Big no-no, and you could check it by picking numbers for a and b. But folks, you cannot distribute over an addition sign. You can't do it. It's a big no-no. So we got a lot more that we need to do here. So what we're actually going to do first on this one is realize, okay, well the a is not happy. He's not happy where he's at. He's not happy in the numerator. So make him happy in the denominator. It's really 1 over a squared. Now, plus, the b is also not happy, so make him happy in the denominator. The whole thing is raised to the negative second power, which means the whole thing is still a little bit not happy. All right, but what we're going to do to add these two fractions together, since we can't distribute with that negative 1, we need a common denominator first. So let's get a common denominator. What's the common denominator for a squared b squared? Well, it's a squared b squared. So we're going to make both of these over a squared b squared. All right, now the first guy, he had a 1, and he had an a squared down here. What did he need? He needed a b squared. That means you got to give him a b squared up top. So whatever you do at the bottom, you got to do the top. The second guy had a b squared, but he needs an a squared to be happy. So that is really, he had a 1, so it's really a squared now up top. By the way, that plus sign shouldn't be there. That should just be a squared b squared. Okay, now you got a common denominator. That's great. And that means you can add the fractions. You're allowed to. So this is really b squared plus a squared over a squared b squared. Nice. Now the whole thing, though, still has this stinky negative 1 up here. So are we done? No, we still got negative exponents. But now we just have a fraction to a negative exponent. Just one fraction instead of 2. Well, guess what we get to do then? Since b squared plus a squared is not happy up top, he gets to go to the bottom. Now he's happy. Since a squared b squared is not happy in the bottom, guess what? Goes to the top. Now he's happy. And guess what, folks? You done. You finished. That's all you got to do. You're absolutely done. Now, if you wanted to check it, you could by just let, A be some number, pick any number, I'll pick 1. And let B be some number, I'll pick any number, I'll pick 2. And just plug them in. So in the original, it had been 1 to the negative second plus 2 to the negative second to the negative first. And on the answer sign, it would have been 1 squared times 2 squared over 2 squared plus 1 squared. Well, the right side's easier. It's really just 1 times 4, so it's 4 over 2 squared is 4 plus 1 squared is 1. 4 plus 1 is 5. So that side's just 4/5. The left side's a little bit trickier. 1 squared is, or 1 to the negative second is really just 1 over 1 to the second. Well, that's just 1 still. 2 to the negative second, he's not happy, so moving to the bottom, it's really 1 over 2 squared, which is 4. The whole thing's still to the negative 1. 1 plus 1/4 is really 5/4, but it's not happy. It's raised to the negative first power. How would you make a fraction happy? You just flip it, so it really equals 4/5. So both times we got 4/5, we're good to go. Okay, let's move here. All right, check this one out. What do you want to do here? So now we've got a binomial over a monomial. What can we do? Well, there's a couple different things you can do. You could say, all right, I'm taking the whole thing and I'm dividing it by the same number. That is, some x to the negative third power. Well, instead of dividing by it, why don't we multiply by it? But remember, he wasn't happy down here. Now he's going to be happy since he moved up. Now it really says x to the fifth power plus x to the negative second power multiplied by x to the third power. And now you can just distribute. And when you have side by side, you add the powers. So it'd be x to the eighth plus x. Can you add those? Does that equal x to the ninth? No, they're not like terms. You can't combine them. If it said multiply, then you'd be fine. So that's a big fat no, and this is your answer. Another way that kids like to do this one is to split it apart. In other words, okay, they rewrite it as two different fractions. They rewrite it as two different fractions. Okay? So now what could you do? Well, you could say, all right, he's not happy, so I move him up. So it's really x to the fifth times x to the third plus he's not happy, so I move him up. He's not happy, so I move him down. X to the third over x squared. Side by side means add the powers, since you're multiplying two terms that have the same base. And monomial divided by a monomial with the same base means subtract the powers. Same answer, different method. Whatever way you want to do it, I don't care. That's the thing about this section, the first two sections really. There's 8 or 9 or 10 ways, it seems like, to do the same problem. But there's no one right way. And so you're just going to have to get comfortable with the laws of exponents in order to be successful. Okay, let's look at this one here. Now here we have a fraction raised to a power. That means the b or the a is raised to the negative second power. Well, they both are. So there's multiple ways you can do this one. Method 1 would be to distribute the power, because you're allowed, since there's no plus or minus sign. So that's the negative fourth power over a to the negative second power. Now, neither one of those guys are happy. So since a is not happy in the bottom, make him happy up top. Oh, he's happy now. And the b, make him happy in the bottom. And guess what? You got no negative exponents. You don't have the same base anywhere. You're done. Another way you could have done that one is said, all right, the whole thing's not happy. When a fraction's not happy, you just flip the fraction. You just flip the fraction, and now the fraction's happy. And now distribute to both of these guys. So it'd be a squared over b to the fourth. Either one of those methods work. I don't care which one you do. Okay, let's do one just a little bit saucier. Let me see if I can erase this, because I'm not so sure that I wrote down the exact right example that I wanted to do there. So I'll switch to blue here. We'll call this number 4, part A. That one seemed a little too easy to me. This actually was supposed to say b to the second over a to the negative second times a squared over b to the negative third power. Now you can probably figure this one out since we did one very similar. I would make both fractions happy first. So I would say this is really a over b squared to the second power, and this is really b over a squared to the third power. And then I would just distribute to both of those fractions. So it's really a squared over power to a power means you multiply. This is really b cubed over a to the power to a power, sixth power. And now this really says, okay, a squared b to the third over a to the sixth b to the fourth. Question, where are there more a's? Top or bottom? There's more on bottom. How many more? 6 minus 2, a to the fourth. Where are there more b's? Top or bottom? Bottom again, right? 4 minus 3, 1. Wait a minute. That means a squared and b cubed went away up top. That means you're left with 1 over a to the fourth b. Done. Finished. No negative exponents, and you've simplified completely. That's all you can do. All right, this is one of my favorite problems from this section. Here you have a monomial, a product of two variables raised to powers, multiplied to a binomial. Well, you've been doing this since pre-algebra. This is just the distributive power, or property. And when you're multiplying two terms that have the same base, such as x, you add the powers. So 5 plus negative 3, that's x squared. And negative 4 plus 6, that becomes y squared. Minus x to the 13th power, and y, negative 4 and positive 3 makes y to the negative first power. So my question is, do you think you're done? We got somebody who's not happy, and you can never finish, you're never done until everybody's happy. So leave x squared y squared alone, but make it minus x to the 13th. Since the y wasn't happy in the numerator, bump him to the denominator. And now he's happy. And guess what? Now you're done. You can't combine anything there because it's separated by subtraction. Okay, now what can we do with this one? Clean this up the best that you can. So we have b to the first power times b to the n power, the whole thing squared, over b to the 2n power. Well, on top, both the b and b to the n are being squared. So multiply the powers. B squared, that came from 1 times 2. And n times 2, that's really just b to the 2n power. Okay, easy enough. All right, now what about this? The bottom is just also b to the 2n power. Now remember, we're multiplying here. So my question is this. Are you allowed to hack and slash those b to the 2n's? And guess what? Since you're multiplying, you certainly can. Hack and slash your way to success. They're gone. Now, if had this been a subtraction sign, or an addition sign for that matter, that would have been a big no-no. No, 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 no. But since there's a multiplication sign, you're allowed. So answer, b squared. You could have also said this. All right, well, the top is just b to the second power plus 2n. Same base means do what with the powers? Add them, minus the bottom power. Well, 2n minus 2n, they gone. You get b squared. Finished. Done. Okay, now here's a different one. Here there are no variables. Okay, what this says is it says 125 raised to the negative third power times 25 over 5 to the negative 8th power. Now, I've got some advice for you on something like this. A red flag should be going off in your head. You see 125, 25, and 5. You should be thinking, can I rewrite in terms of the same base? Because if I can, then guess what? Then the laws of exponents apply, and I might be able to simplify this bad boy. But if they're not in the same base, nothing you can do. Well, 125, that's really 5 to the third power, folks. Think about that. 125 is really 5 to the third power. Well, that really just means this says 5 to the third power to the negative third power. Well, and 25 is really 5 to the second power. So this really just says 5 to the second power. And the bottom is already in terms of 5. Well, sweet. Now I can use my laws of exponents because everything has the same base. Power to a power means you multiply, multiply. Hopefully you're saying it with me by now. Times 5 to the second power over 5 to the negative 8th power. Side by side means add them, add them. So add the powers. That's really 5 to the negative 7th power over 5 to the negative 8th power. Who's not happy? The top 5 or the bottom 5? Neither one of them are happy. So move the bottom guy up. Now he's happy. Move the top guy down. Now he's happy. Mono divided by mono means subtract. Subtract. Where are there more 5s at? At the top. How many more? 1. So that really just equals 5. And you can confirm that on your calculator if you have to. You can confirm that on your calculator. Watch, I'll show you. So just pull out your calculator, type in the original problem. The original problem was 125. Oh, got to turn it on. Let me put some parentheses around this. So 125. It was raised to the negative 3rd power times 25, close your parentheses, divided by, probably need parentheses here, 5 raised to the negative 8th power. Answer. And looky there, that's what we got. Sweet. Okay. So now this one's a little bit saltier because now you got variables. So you can't just go run to that calculator. All right. But we can kind of use the same idea we did last time. 125, 5, and 25 can all be rewritten in terms of 5. Most of the time you can rewrite in terms of like 2 or 3 or 4 or 5. All right, so that's really 5 to the 3rd power, but it's being raised to the n power still. This is 5 to the 4n. No need to touch him yet. And the bottom is 5 to the 2nd power. But it's still raised to the negative n power. Well, now you have power to a power. What do? You multiply them. So that's 3n times 5 to the 4n over 5 to the 2 times negative n is just negative 2n. Okay, now what can you do with those powers? You can add them, So 3n plus 4n is 7n because they're like terms. Now, is everybody happy? No, no, no. He's not happy down there. So where do you move him? Move the whole base up. So it's really 5 to the 7n times 5 to the 2n. And side by side means you add them, So this really says 5 to the 9n power. Question, are we done? Well, we're not, because we completely left out the fact that this whole thing has a cube root over it. So how does that work? Well, let's think about this. If you'll remember from Algebra 2, you should have learned, I'm going to make a special note here, that anything to the cube root is really raised to the 1/3 power. Just like the square root is really the 1/2 power. It's the same thing. So this is really 5 to the 9n to the 1/3 power. Well now I have power to a power. Can you multiply 1/3 times 9n? Sure can. This really says 5 to the 3n power because 1/3 of 9 is 3. And that's it. Alright folks, laws of exponents takes a lot of practice. You're not going to get this your first try. You're going to practice, practice, practice. That's all I got for part 1. I'll catch you later. I'm out.